In this video, we're going to consider the surface area of a cone, and this is quite different to finding the volume of a cone, where we need the perpendicular height. When trying to find the surface area of a cone, we need the radius, but we need the slant height, not the perpendicular height. So very important distinction between volume and surface area of a cone. And the formula is just simply pi r squared, so that's the surface area of the base, which is just a circle of radius r, plus pi r L. Now, the proof of this I might do in another video, so I'm not going to explain where that comes from in this particular video. Now, if you want to express this in factor form, so just a factorized version of this, it might be a little bit quicker when performing a calculation. Just factorize pi r out of the formula, so area is equal to pi r outside of r plus L. Now, just be mindful as well that you may get a question that asks for the surface area of an open cone, in which case you just omit the pi r squared. So there's no circular base, or depending on sort of the orientation of the cone, whether it's upside down or sort of the apex to the top, but there's no circle or circular component to it. You just have the curved surface only, and the formula is simply just area is equal to pi r L, where L is the slant height. Let's have a look at an example. Find the surface area of the following cone correct to three significant figures. So we have here's our cone. We have a radius here, so 8.9 centimeters. So I'll just put an R there. Now we're given the perpendicular height, but you know that we can't use that, not directly anyway. So we need the slant height. So you need this L. Okay. Now, hopefully you've noticed here that we have a right angle triangle, so we can use Pythagoras theorem to find L. So let's do that. So L is equal to, in fact, the square root of 8.9 squared plus 11.5 squared. Now, I'm not going to evaluate this. I'm just going to leave it in just an exact form. So I'm going to do all the rounding right at the very end, just to sort of minimize any rounding errors. Now we can apply the formula for the surface area of a cone. So area is equal to pi r squared plus pi r L. Okay. And that's equal to pi multiplied by, now r is 8.9, and we'll square that, plus pi r L. So pi multiplied by 8.9 multiplied by L. Now L is just the square root of 8.9 squared plus 11.5 squared, which is in fact the hypotenuse of this triangle. And now we can just enter it into the calculator and evaluate this expression directly and round it accordingly. So I might just zoom in on the calculator there, it's the calculator screen. So it's going to be pi r squared, so shift pi multiplied by 8.9 squared, that's pi r squared, plus pi r L. So pi multiplied by 8.9 multiplied by the square root of 8.9 squared plus 11.5 squared, and we get 655.433. Okay, so is equal to 655.433 ... So it keeps going on, and that's square centimeters, because we are dealing with surface area, not volume. But we need to round this to three significant figures. So starting from the most significant figure, the 6, we've got two other figures as well after that. So 1, 2, 3. Do we keep this 5 here as a 5, or do we round up? Well, that depends on the digit after the 5, which is 4. So we just leave it as 655 square centimeters correct to three significant figures.